in control system, to find the model of the system, generally we write differential equations or integral differential equations. By applying the Laplace transform, we can find the transfer function, or we can also find the state space model. But there are certain systems where governing equations are not possible. So in that case, we can give the sinusoidal input to the system, then we can find out the open loop frequency response. So from the frequency response, we can find the model of the system. Now we will see how to find the transfer function of the system from the magnitude plot, which is the open loop frequency response of the system. Now look at some of the steps which we need to follow to find the transfer function from the magnitude plot. In bode diagram, we have both magnitude and phase plot, but magnitude plot is enough to find the transfer function. Now, so step 1. In step 1, we are going to look at what are the corner frequencies of the system. So if you have corner frequencies omega c1, omega c2, omega c3, just list out what are the corner frequencies. So once the corner frequencies are available, then look at the initial slope of the magnitude plot. So there are many slopes in magnitude plot. Each and every corner frequency, the magnitude plot is going to change its slope. So let us say this is a one slope which is coming, again it is a straight line, it is coming down. So likewise we have different magnitudes and their slopes. So number of slopes gives the number of terms in the open loop transfer function. If you have 3 slopes including initial slope, which means there are 3 terms in the open loop transfer function of the system. Now we'll take one by one. The first is initial slope. So by looking at the initial slope, since we have a slope is available, and I just have this table, from this table you can write out the corresponding initial first term. So what is this table? So if at all, if the slope is plus 20 n dB for decade, so plus in the sense it is 0, 20 n is a number of such zeros we have. The corresponding is k into s power n. So k s power n is the first term if at all the initial slope is plus 20 n dB for decade. Similarly, if you have minus 20 n dB for decade, which means my term is going to be k by s power n. So k by s, there are poles, therefore I have minus, so minus 20 n dB for decade. Then if at all if you have 0 dB for decade, which means the corresponding term is simply k. So there are only 3 possibilities, k, k into s power n, k by s power n. By looking at the initial slope, then we can find out what will be the first term in the transfer function. So in the second step, step 2, we know already corner frequencies. At each and every corner frequency, what is the next slope, what is the previous slope. So at corner frequency, we have 2 magnitude plots, means we have 2 slopes. So one slope which is coming, the other slope which is going. So after corner frequency, what are the slope we have? Let us, that is the next slope, and before that, that is the previous slope. So at each and every corner frequency, then you identify what is the next and previous and find out the present slope at that particular corner frequency. That means your present slope at that corner frequency is next slope minus previous slope. So once the corner frequency omega c1, at each omega c1, if you know the its slope, then you can easily find out what is the corresponding term. Now look at the table. So in this table we have the slope and as well as we have the term. So if the slope is plus 20 n dB for decade, then corresponding term is 1 plus s by omega c whole power n. So it is a finite zero or finite pole. So if your origin poles, origin zeros, that is from only initial slope we can find out. The remaining terms will be finite poles and finite zeros. So at each and every corner frequency, then we can write like this: we plus 20 n dB for decade, then we have 1 plus s by omega c power n. Then if it is minus n 20 dB for decade, then it is going to be 1 divided by 1 plus s by omega c power n. So this way we can find out what are the corresponding terms for all the corner frequencies. So once the corner frequencies terms are available, then we can easily write in the transfer function model, the skeleton is available to us, because the transfer function is k into all the finite terms divided by all the finite zeros, all and finite poles. And of course, so we have the first term, either it may be k or k into s power n or k by s power n. So then how to find the k value? So k value we can find out by using the initial slope. If you look at the initial slope, from the initial slope, let us find out what is the known frequency and corresponding what will be the MdB value. So known frequency and known MdB value of the first slope at any point, maybe the starting point, ending point, in between, anywhere, if we know frequency and its corresponding MdB, then we can find out the k value. So for example, if you have the first term is k, then how to get this k value? Then you know the MdB value, then MdB value is equal to 20 log k. Because when you have a type 0 system, you know, you will get only k. So in that case, the frequency is not needed. So directly MdB is 20 log k. Then we can find out the k value. If it has the first term is k into s power n. So in this case, then we can write it as with known MdB value. You can write 20 log k plus n 20 log omega. So omega you know, and also MdB you know, you can find out what is the k value. Similarly, third possibility is k by s power n. If you k by s power n, then what is the corresponding MdB expression? You know the MdB value, that is equal to 20 log k minus n 20 log omega. So omega you know, MdB you know, then if you equate that, then you will be getting k value. So this way we can find out k, and all the finite terms, that means finite zeros and finite poles, you can find out from the step 2, and the initial, the first term you can find it from the step 1. When you write all the terms, then you will be getting the transfer function. Now to understand this method, let us take some examples. Look at this problem, and the problem statement goes like this. Obtain the transfer function of the system whose magnitude plot is shown below. So this is the magnitude plot. So for this magnitude plot, we need to find the transfer function. As I said, in bode diagram we have both magnitude and phase plot, but magnitude plot is enough to find the transfer function. So we have the steps, we will follow those steps and we find out the transfer function very easily. Now if you look at here, there are 4 slopes. So I have the curve like this, one slope which is coming down, and I have this is 0 dB for decade. In fact, it is given and it's going up and is coming down. So there are 4 slopes, which means in the transfer function there are 4 terms which we are going to see now. So what I said, first identify what are the corner frequencies. Now corner frequency I have, this is a one corner frequency 2, this is another corner frequency 5, and that is another corner frequency 10. So I have 3 corner frequency. At each corner frequency you will be getting the finite terms, right? Now I have the initial slope. What will be the initial slope? In this case it is given it as minus 40 dB for decade. If you have minus 40 dB for decade, we can write it as minus 2 into 20 dB for decade, which means minus indicates there are infinite zeros, infinite poles, and there are 2. 2 means there are 2 such poles. Then what will the first term? The first term is equal to k by s square. Since I have minus 40 dB for decade, it is k by s square directly. Then in step 2, each and every corner frequency we write next slope minus previous slope, so that I will get the slope at the corner frequency. Now let us say omega c1 is 2 radian per second. So at this I just want to know what is the present slope, what is the slope at that particular corner frequency. That means the contribution of the slope of at that particular corner frequency. So it is very clear from this diagram, we have already 0 minus 40. So it results in 40 dB for decade. So I have plus 40. Plus means it is 0. 40 I can write it as 2 into 20. Therefore, there are 2 zeros at this corner frequency. So that means there are 2 finite terms. So I can write it as the corresponding term will be 1 plus s by omega c1. The omega c1 is 2. So 1 plus s by 2 whole square. So this is the term that is there at omega c1. Then similarly we can find it at omega c2. So at omega c2 it is 5 radian per second, then it will be 20 minus 0, it is going to be plus 20 dB for decade, and s 1 plus s by omega c2. So 1 plus s by 5. Then at third corner frequency we have it is minus, already we have minus 20 and minus 20. So that is going to be minus 40. So minus 40 means there are two finite poles, that is 1 by 1 plus s divided by omega c3 whole square. So that is 1 plus s by 10 whole square. Then now with these terms, then I can write the transfer function as, my transfer function is equal to k as it is there. So k by s square we have the first term, therefore k into, I have 1 plus s by 2 whole square into 1 plus s by 5 divided by, I have s square already there, plus 1 plus s by 10 whole square. So this is the transfer function. I can simplify again further, like k by s square as it is there, 1 plus 0.5 s whole square and 1 plus 0.2 s divided by s square already there, 1 plus 0.1 s whole square.